Hey folks, so in this video we're going to take a look at how to implement linked lists in C. Now linked lists are a common data structure. You've probably already seen them, but it'll have been in a language like, for example, Java, where things are just a little bit different. Obviously there are many different nuances to the C implementation of data structures in general. So in this series of videos what we're going to take a look at is how we actually implement linked lists within the C language. So let's start by kind of refreshing what is a linked list. So linked lists are made of things called nodes. So the idea is that we have different compartments where you can store information. This is perhaps similar to the idea of an array. The idea of an array is having kind of this contiguous setup. For example, something that looks like perhaps like this in memory, like a little space somewhere where there are these little slots where I can store things back to back, right? So arrays typically are drawn like this. Maybe I have an array and I call it M, right? And I store, A here, B here, C here, right? And they're all back to back. That's a very typical thing. That's a simple data structure. Now, lists are a little bit different. Instead of having this kind of back-to-back idea of things being stored one after another in memory, they instead are made from these things called nodes. Now, there is one example here on the slide of a node, and you can see I have basically this box being drawn with a 3 inside of it. This is very typical for linked list notation. The notation typically is to have this box which contains actually two things. First of all is some value, right? So what am I storing? Maybe I'm storing something like an A, like I had in my picture above for an array. So I'll have that in there, and also have a little annotation at the top to represent something we call the next variable, or the link to the next item in the list. So the idea is that a linked list, the way it stores multiple things, is by being constructed from multiple nodes. Now here I have just a single node, the node with the source A, but I could also think about creating perhaps another node, which has maybe something like, for example, that B in there. In which case my picture would look something like this, where I have another node being drawn, and I have this linkage from the first node to the second node. So I can see here, right, that if I maybe know about A, there's a way, right, there's an arrow to get me from A to B. And I can actually chain these together. So for example, maybe I have my C over here, like my picture above. That would mean that I need another node, and now B would be linked to this new node, right? So I have these three things that are now connected. So these are each the individual parts, right? And again, this is standard notation. Standard notation is we show the value inside of a node here, and then a reference to next over here, right? So next meaning, where do I go to get more information? Now here we're drawing it directly as arrows to represent that if I'm at A, I can find out, or I can kind of get to B, right? If I'm at B, I can kind of get to C, and so on. So this is a typical structure of a linked list. And you can kind of see, right, where the name came from, right? The word in there is linked, right? And you can see these things over here, these are links, right? I have a link from A to B and B to C. Okay. So this is our basic structure. So this is a node, right? And as a whole, this is a list. Typically when we have this notation, we'll write something like, for example, a variable name. And let's try this, I don't know. We'll call this maybe front. And we typically write that as having, for example, an arrow out of the variable name to a node, which represents I have a variable that stores a reference to this first node. Okay, so that would be a variable in my program that knows kind of where you start. So let's say we have this picture here. Now what? So what we want to do basically is implement this inside of C. Now you've already seen this, for example, in using class in Java. C is going to be a little bit different. So a couple of big things for us. First of all, we're not going to be able to construct these nodes using a class, which is what you may have seen before. Instead, we're going to have to use a struct, since a struct is the basic way we have to basically combine together different pieces of data in C. The second thing is we have to think about how we connect these. Now, in a language like Java, it's actually pretty straightforward. We only have to worry about having a new variable, which is really just the name of the class, because we're going to store an object, and that object somehow represents the next node in this list. Now, for us, it'll be a little bit different. And instead, what we're going to have to do is we're going to have to use pointers. So in C, right, we have this idea of pointer types, which are types that store an address to somebody else. Well, that's actually what we need here. So A will have a variable inside called next, which is effectively a pointer to another node, right? It tells us where do we go to get more information. That's how we'll link our nodes together. Another thought here before we go and kind of continue with this is how do we represent an empty list, right? So I've drawn here a list of three variables, but what happens if I don't have anything at all? Well, in that case, we can actually use that C keyword, right? There's actually a C keyword which is called null, and it's all uppercase, and what it is basically used to represent, maybe a pointer variable that hasn't been set to something useful, right? We just set it equal to null. It's kind of like setting it equal to 0. And that's what we'll use for denoting an empty list or even the end of a list. So in my picture over here, I have, for example, my C variable here, or my C node over here. Notice I don't have an arrow coming out of this thing. Well, really that should be pointing at or storing the value of null, right, to represent that it's at the end of the list. All right, so those are the basic concepts of a list. Hopefully that's a little bit of a refresher. So now we're going to do a little bit of editing magic and go and try to actually implement one of these inside of C. Okay, so now we're over here in NetBeans running under Xubuntu. So what's the plan? What I want to do is first create a linked list node, and after I create a linked list node, try creating copies of that node and perhaps either adding information to it or reading information from it. So let's try doing this. So my first step is to basically create a linked list struct. This is going to be a struct that represents a node inside of my list. So let's go ahead and start just implementing this. So what I'm going to do here is use an example of a contact book or an address book. Basically what I want to have is my different nodes containing information like somebody's name, their phone number, their email, and so on, right? So that's maybe something that I want to store. So let's see, what should I plan to store? Let's actually write those down. So we'll put in a name, we'll put in a phone, put in an email, and that should be enough. Okay, so what I want to do basically is write a struct that can store all of these things. Okay, so let's see, what should I do? Well, first of all, I need to actually define the struct, right? I need to have this new type being introduced. So here I'll go struct, and I'll do something called, let's go for contact node. So this will be my node that I'm building out. And I want to eventually add those three things to it. So this will be my new node. Okay, now I need stuff inside of it. Let me think for a second, what are the types going to be? Well, name's going to be a string, phone could probably be like an integer, and then email will be a string again. All right. Now, one thing to note here is that, name and email are both strings. This maybe is a little bit problematic for us in C because arrays need to have some sort of well, it's best if we have a fixed length associated with them, right? Then we can do our memory allocations a little bit easier. So what I'm going to do before I actually go and add these things is I'm going to actually make kind of a special definition to define how long a name can be or how long an email can be. So I'll back up here for a second and put in this over here. Define of, let's just call it max length. So this is a variable that will store the maximum number of characters that I can have in a name or an email. And we'll just give it something a little bit large, 1024. That sounds reasonable. All right, so I have that. Let me go back and finish writing my node. So my data, right, are these three pieces. So how do I do this? Well, first of all, I want to create a character array to store the name. So I'm going to type in here basically character name of max length, right? Because that'll create me a brand new array that stores this number of characters. Okay, that looks good. My ID is not even complaining. So let's keep on pressing forward. What do I do next? I need to create phone, so I'll create another integer. Well, my first integer, I suppose. Point is, it works. Everything is good. All right, email. What do I have here? Let's see, a character again array, and I'll do that called email, and I'll put in maxlen, because that again is telling me this is how many characters you're allowed to have in your email address. All right, so that looks pretty good. We've stored a bunch of data here. Again, our example here is we're just going to store information, contact information, right, like somebody's address book or something like that. Okay, so what do I need to have here? Well, this is a linked list node, and if you remember back from that picture we drew, we need to have what's called a next reference. We need to have a way to get from one node to another node. So how do I do that? Well, what I want to do is I want to create a new variable that's a pointer type to the same kind of node struct, right? I want to know where to go find a new one of me, right? So how do we do that? Well, we know our variable is going to be called next. That's just kind of a common term, so I'll go ahead and type that in there. But what type does it need to be? Well, we want to link to ourselves, and we are basically the struct contact node, so I'll type in struct contact node. And then at the end, I'll have to basically put in a star because, oh, hey, I need a pointer, right? I want to store a reference to where I can go and find more things. All right, so this looks pretty good to me. Assuming I didn't make any typos, that should be a functional linked list. And I'll clean up for a second. I'll delete my comments a little bit there. I'll delete this over here as well. And there, we have basically a linked list node that's been implemented. So that looks good so far, but obviously until we test it out, we don't know whether it works as we want to. So let's try that. Let's start by basically creating a node, adding some information to it, and then maybe reading it back out. So how can I do this? Well, first of all, if I want to create a new node, what I'm going to do is have to create some sort of a variable to store it into. Now for this, I'm going to use dynamic memory allocation. This is kind of not really necessary for us here, but in the context of linked lists, and there's an idea there of linked lists being something where you can easily add or remove elements to, well, we want to have this dynamic sense, right? We want to have support for that. And so I'll go ahead and show you kind of that approach here. So the first thing I need to do is basically define a variable to hold the new node that I'm going to play with. So how do I do that? Well, first of all, I got to define the type, right? It's a new variable. And the type here will basically be this struct contact node because, oh, hey, that's the name of the node that I'm trying to build. So struct contact node star. Okay, so I have that. I'm going to call this variable just for now n. And I really should call it something longer, but I don't want to type out all that much. So I'll just call it n. Okay, now here's where maybe things are a little bit tricky. So what we want to do is basically initialize this variable, and I want to initialize this variable by requesting the system enough memory to store the node. Now in C, the way we request memory is by using the function called malloc, right? So malloc will let us request from the operating system some memory to store things into. So let's call malloc. So we do malloc, and malloc takes some parameters. So what are the parameters? Well, malloc is basically a tool for requesting a certain number of bytes from the system. So in order to use it, what we want to do is we want to pass in the number of bytes of a contact node. So what do? We'll type size of, right? So size of is something that I can basically give it a type, and it'll tell me how many bytes does that type take. So size of, so then we'll put in our struct contact node, right? So how large is a contact node, right? That's our question here. Okay, so that looks pretty good. And I see my compiler is not complaining, or my IDE is not complaining, which I was rather hoping it would. This may actually require a little bit more work if you're on a different IDE, and I'll show you the rest of the work that sometimes is required, which is this. It's a cast, right? So malloc, right, is a very general tool. It's just returning a pointer to a bunch of memory. But sometimes what we basically need to say is, oh, hey, the type of memory is the memory intended for a contact node. And so we do that with a cast to say, okay, malloc is returning, this contact node memory, right? A pointer to this new contact node memory. But anyway, either way, right, depending on whatever you need, right, you can implement it however you want. All right, so looks good so far. As a quick note here, this malloc command, I need to make sure that I have this stdlib.h file. So this is actually was already in here. I actually started the day basically with a blank NetBeans project. That was already in there, which is nice because it lines up with me using malloc. If you're using something else, right, maybe that wasn't already available and you'll need to bring it in manually. Okay, so I have my struct here created. Let's try adding some information. Let's try first adding a phone number. That'll be kind of the simplest thing. So I'll go n arrow phone, right? Remember I need an arrow there because n is basically a pointer, right? I want to basically go look inside of it and store something into it, right? So I need to do, instead of doing a dot and a star, I'm just going to combine them together and do that arrow thing. All right, so n arrow phone equals, we'll give them the phone number 1337, just cause. Okay, so maybe what we should do now is just go ahead and try displaying stuff. And hopefully we can get something that'll compile and won't crash on me or anything. So yeah, let's try that. So I'm just going to see basically if that value stuck in there, right? Did it get stored properly? So I'm just going to go and basically print out, what is the phone number? So phone number is, and then %d. Okay, and I want to pass it something to print out. Well, I'm going to pass it n arrow phone. All right. So if all is good, I should run this and it should print 113, or phone is 113. So let's see what we get. Let me do a build and a run. And I get a build fail. Okay, so that's not actually what I'm expecting, but I think we should be okay. It's actually complaining here. That's the errors over here. Multiple definitions of main, which is right. I actually have two files in this one project in NetBeans that both have mains. So let me actually go over here really quick, and we'll just put in some gibberish over here so there's no longer a main. You can only compile a program if there's one main in it. If there's more than one main, it won't work because basically the program doesn't know where to start. Like, which main do you want me to start with, right? So you can only allow to have one main. All right. So I fixed that, and it won't be an issue on your guys' end, right? Unless you have other files in your project. So don't worry about it too much. But anyways, I fixed it. It looks like it works now. So now you can see phone 1337. All right. Let's maybe try just one more here. Let's try a str copy. And let's see if we can store, let's go and we'll go to name and we'll try storing Wonder Bread as the name. So there we go. So we're storing or trying to store, and this is misspelled, no it's not misspelled, into this variable here, right? So hopefully our string is now going to contain that as well. So I'll kind of update this over here. So we'll go name and we'll make it display a string. And over here we'll go n arrow name. Let's go ahead and run this. So hopefully I see my name and my phone number. It runs, and there we go. Name Wonderbread, phone 1337. All right, so there you go. So that was a simple implementation of a linked list node in C. We did both the actual implementation of the node as well as some little bit of playing with it, see if we could load data into it, see if we get data back out of it. All right, so that's all I got for you guys in this video. In the next video, we'll start looking at how we can actually modify or create these linked lists.